Welcome to Smith Weekly Discussions, an occasional program for our readers and listeners of Smith Weekly Research. Please note this program is a private discussion and everything contained herein is for entertainment and educational purposes only. With that, we hope you're in a comfortable position, along with your favorite beverage, to enjoy the discussion. We remind our audience to examine the show notes attached to each of our shows to better understand how our program functions. Before we get into our discussion, we want to say thanks for questions coming from the audience at Smith Weekly, including Luke A., Cindy W., and Mike P. We've got a brand new guest on the show today. Liz Muller is here. Liz is Chief Executive Officer at Deep Isolation, a nuclear energy industry focused company advancing a disposal solution technology for nuclear waste. You can learn more about Deep Isolation and their work via their website, deepisolation.com. Liz, thanks for coming on the show. How are you?
I'm doing great. Happy to be here, Andrew.
Well, Liz, we typically start out with new guests covering their background and experience. So maybe we can start off by having you tell us about yours.
Sure. For the past 10 years, I've been running an environmental group, so an environmental nonprofit by the name of Berkeley Earth. So we've looked at big data analysis, global temperature analysis, air pollution analysis. In addition to the analysis, we've also looked at how can you do things with the analysis? So not just the actual results of what you get when you look at the data, but what does this mean for policy? What does this mean for people who want to make a difference in the world? We have had a focus on global warming and as well as air pollution, and nuclear has grown out of that interest. Nuclear power, not only is it clean from the perspective of emissions and greenhouse gases, but also from an air pollution perspective. So that was the initial interest in nuclear. And I got into this business, I think, just by being in the right place at the right time.
I want to talk about a few things that you just mentioned in a moment, but what brought you over to Deep Isolation, and how did the idea behind Deep Isolation really come about?
Yeah, so Deep Isolation grew out of our interest in nuclear power. So as part of Berkeley Earth, we were looking at what are the big things that are needed if we're going to stop global warming. And nuclear was definitely on our list. But at the same time, we are aware of the nuclear waste problem, or the, quote, unsolved nuclear waste problem, which has been an issue for people who want to promote nuclear power. People ask, can it really be considered clean if we haven't solved the nuclear waste problem? And I think there's a point there. I think that it's a relevant point. I think that we need to support responsible nuclear. And part of being responsible is making sure that you have a solution for the waste. At the same time, I was also very familiar with natural gas, and in particular drilling, also part of the work that we had done on air pollution. And so directional drilling is really an incredible innovation that has been developed in the past 2 decades and is now very standard. It is inexpensive, and it allows us to put nuclear waste into deep geologic isolation, which is the international consensus of where it needs to go, without necessarily mining out a cavern and putting humans underground. So it allows us to have a safer and cheaper way of putting nuclear waste into deep geologic isolation that I think is really the key concept behind the company, and has allowed us to do this work over the past 4 years.
Yeah, certainly a lot of developments on that front, and the shale revolution in the U.S. I think has been a game changer for the global oil and gas markets. And we used to spend a lot of time in other countries looking for oil and securing oil assets, when in fact we had a whole bunch under our nose that we could probably never use. Certainly an interesting concept behind deep isolation using this technology. Before we get into deep isolation, I'd like to get your high-level view on the energy markets at this point and what you believe should be the focus when it comes to best energy sources.
I'm a big believer in options, all of the above. I don't think it's our position to try and pick and choose technologies of the future. I think the smart thing to do is to support all of them and to see what then makes the most sense from a financial perspective, business perspective, environmental perspective, et cetera. I do think that nuclear needs to be part of that mix. I don't think it's the only part of that mix. I think we need solar, we need wind, we need natural gas. We may even need coal for a while. I'm also hopeful about carbon sequestration technologies and as well as new innovations that we haven't even heard of yet. I'm not going to be able to give you a firm answer on what I think the energy market winners are going to be, but rather I think we need to support all of them.
Yeah, and I think there's some other components to it, just to the point that certainly nuclear is one of those sought energy forms. It's kind of really the superior form of energy that's out there. You can do a lot of different things that nuclear offers on these energy fronts. And people talk often about the pollution from different energy sources, the waste footprint. When you talk about pollution energy, you certainly talk about coal. But when you talk about waste, there's always this highlight around perception of nuclear waste. But in fact, the waste from wind and solar, wearing out short time periods of component life, replacing turbines, panels, batteries, etc., and where all this stuff goes after it gets demolished and hauled away and replaced is a big waste question to me that I think is generally unanswered. Wind and solar, highly promoted right now and have been, maybe not the most sensible from an uptime standpoint and obviously from a footprint standpoint. What's your thoughts on, big solar fields and deserts, huge land packages being used for solar and wind on the ocean? Any thoughts on that front?
Yeah, I think there is a role for wind and solar. I'm not very optimistic about 100% wind and solar. I'm not even very optimistic about 50% wind and solar, but I think 30% or somewhere in that range is probably reasonable. I think we're getting there. I'm probably not as optimistic as some of the heavy promoters. I think there are still some unsolved issues. I think batteries, storage, cost is coming down, but cost is one thing when it's the middle of a windy and sunny day. It's something else entirely when there's no wind and there's no sun out. So I do think that there are a number of issues that still need to be addressed.
And on California, you're in California. Energy policy there, a little bit silly, among other things. But Diablo Canyon, Liz, do you think that'll stay online?
So I think that's an important question. I don't know the answer to that. It's not looking good. I think another part of nuclear that is frequently missed is the consent issue. Now, yes, this is true also for wind and solar. Not all people who are near wind and solar plants are happy about them. So this is not specific to nuclear. But I think for all energy sources, making sure that the community that is most impacted by whatever energy source you're using is comfortable with that is a really important element that unfortunately has been lacking.
And I got to ask you a little bit about nuclear fuel supply chain for a moment. Otherwise, our audience would be unhappy. Where do you see with deep isolation really being on the downstream end, the remediation, recycle, storage, disposal end of the supply chain? Do you have any thoughts that you'd like to share about upstream industries in the nuclear industry, areas like uranium mining, upstream fuel cycle? Any thoughts on that as part of your guys' study into the supply chain of the sector?
Well, we haven't done any direct studies of that, but I do think that there's a big question about the future of nuclear power. And if the future of nuclear isn't going to be just to recycle the current nuclear waste, but is going to be that we should develop new nuclear that potentially requires some mining, I think that in order for that to move forward, the nuclear waste problem is an essential component of that. It's one that has been largely ignored, but I do think that the future of nuclear can be very bright. I think there are reasons to look at all different types for the future of nuclear, so not just the recycling of current waste. So that's my perspective on it. I think that we do need nuclear, and in order to use nuclear, we need to solve the nuclear waste problem.
So talking about nuclear waste in general, we know that waste is certainly a contentious matter in some communities, but in reality, the waste footprint is really small when you compare it to other forms of energy sources, whether it's oil, gas, coal, whatever. It's highly secure. It's safe as compared to e-waste, a replacement component footprint, component life turnover, et cetera, other waste supply chains issues that we have with other industries, also the environmental damage. Nuclear waste really sits in a location that's secured. It does nothing. It's safe. It's small. The total nuclear waste storage facilities around the world constitute a very small footprint. Why do you think nuclear waste is so popular, Liz? Is it because of the past perception of nuclear weapons? That current perception still prevails? Accidents, radiation? Why do you think it's such a popular issue?
It's the right question. I think that nuclear waste is scary. I mean, you're right. It's compact, it's dense, it's easily contained, et cetera, et cetera. And yet it's also extremely dangerous. And there's no other waste form that if you held, or if you even went into the same room as some of it, it would kill you, right? So it's different in the impact that it could potentially have, or at least the way that we perceive the impact that it could have. I mean, I think everything that you said is fair and right, and yet at the same time, people do care about nuclear waste, and you acknowledge that, and it is the single biggest reason that so many people don't support the future for nuclear power. And so rather than trying to convince the world that they shouldn't be concerned about nuclear waste. And I should also point out, I also think there are some reasons that we maybe should be concerned about nuclear waste because it is secure now, but what about in a million years? How secure is it going to be then, or in 500,000 years? And the fact that it needs, if it's going to be on the surface, it needs guards and guns, is a little bit worrying when you start thinking out for very large time horizons. And I also think it's a solvable problem. I think this idea of we don't need to solve the nuclear waste problem and it's too hard, so we're not going to try, we're just going to leave it to future generations, is not helping the nuclear industry. I think it's not an unsolvable problem. I think it's solvable. I think it's solvable in relatively short time frames. And if we simply had the political will to get it done, and to allow innovation, to allow new ideas such as deep isolation, I think we could solve this problem and just remove it from the lists of reasons to oppose the future of nuclear power.
Yeah, absolutely. I think you make some good points. And, I would just remind folks to also keep a perspective that nuclear waste in the form that we're talking about here generally has a very, very small reputation, if any, for causing deaths. Whereas coal, for example, uncontained, uncontrolled, gets burnt, we breathe it, et cetera, especially in areas that still have coal plants. Just think of the numbers from that. And so I would just remind people to try to keep it in perspective. But it certainly is an issue. And I think that some of the thought processes behind it make a lot of sense. Let's get into deep isolation here. Give us a quick 1-minute overview, and then let's get into the corporate structure of the company.
So deep isolation is bringing together innovations in drilling technologies with nuclear waste, and ways of putting nuclear waste into deep geologic isolation, which is, again, as I said earlier, is the consensus for where it needs to go. So key ideas, you can use directional drilling. You can drill down a mile or so, half a mile, as deep as you need to go in a particular location, and then turn very gently and then go horizontally for a mile or two. And this provides you with a very secure location where you can store quite a lot of nuclear waste. We're looking at tens of holes required per reactor on average. It depends a little bit on the specifics of the reactor. So not a large footprint. And it also is modular. So rather than requiring one single location for a country, or for a very large region, and then requiring transportation to bring the waste to that location, this could be implemented in many, many locations around the world, which helps with some of the concerns around transportation, but also equity and not in my backyard. Nobody really usually wants to be the nuclear waste dump for an entire country.
Yeah, certainly. I'm sure there's some landowners out there that would sell you some space. But you're absolutely right. And by the way, with the oil and gas industry, these depths, these directions have already been drilled and deeper, much, much, much deeper.
That's right.
So for folks who are wondering, well, this is new ground. No, it's really not at all. It's very, very cut, dried, straightforward. Well, let's talk about the corporate structure. The company is private at the moment. Can you
Yes.
cover the major shareholders backing the company, Liz, and talk about how you guys raise capital to continue operations?
Sure. So we just closed a Series A round, which was led by our partner NAC International. So they are a nuclear waste transportation, storage, and consulting company with tremendous expertise when it comes to the handling, the packaging, and the safe storage of nuclear waste. So they're in many ways a fantastic and natural partner for us. We can use their expertise on much of what we do. We are designing a canister together with them, which we will seek to get licensed for the disposal of nuclear waste using the deep isolation technology. They were our lead investor for our Series A. We have raised other capital, which has been to date from individuals. So pretty significant raise without institutional capital beyond NAC's contribution. And I think that's because we haven't really been a fantastic fit in the past for venture capital. And I think we were a little bit too small for more investment either on the nuclear side or the oil and gas side. But I do expect that to change with our upcoming Series B sometime in the next year or so.
And Liz, do you see that some nuclear utilities would be an interesting partner for potential shareholders going forward? Do you guys see that that would be a key entity organization to have along?
Absolutely. So the utilities are not directly involved, at least in the United States, with nuclear waste disposal. That is left for the Department of Energy. But they are deeply involved with the nuclear waste temporary storage. And given that the US government has not been making a tremendous amount of progress towards a nuclear waste disposal facility, this is becoming more and more important. And it's particularly becoming more and more important for new nuclear. So whereas there is an agreement that the Department of Energy will take the nuclear waste from the current reactors around the country, it's much more uncertain what's going to happen to any new nuclear waste that is generated going forward.
The canister for the deposit system, I'm assuming you guys are probably using like materials, similar materials to what is already approved for the CAS, the storage CAS from the NRC. Is that process an NRC application process? Liz, just run through that real quick as far as that approval process.
Yeah, so the licensing process will probably begin with the licensing of the canister. And it'll depend a little bit if we start in the US. So we're not sure that we're going to start this process in the United States. It might make more sense to do it elsewhere. But generally speaking, there are different types of licenses. It may make the most sense to start with a canister to get that licensed, probably to get it licensed first for above ground temporary storage. So now we're talking about temporary storage that is disposal ready. So providing an element of flexibility for new nuclear waste that is generated, doesn't have to go into a temporary storage that might then need to get reopened and put into a different type of storage facility for eventually going into disposal. So that's probably where we would start. After that, we'd probably look at full deep isolation underground facility, but also still for temporary storage. And we can do this. We can put it into the full deep isolation borehole technology and call it storage because it is retrievable. And so you could go down and get it out and move it or do something else with it in the future if you decided that was the right thing to do. But what this bridge would allow you to do is to then come back in, maybe it's 5 years time, maybe it's 10 years, maybe it's 15, and say, okay, now we're ready to call it disposal. And so we could put it into a deep isolation temporary storage facility that is intended to become a disposal facility when the time is right in the future. And so that's probably the licensing process that we're most likely to follow.
Interesting. Okay. And just back to the company here, key people that, have been instrumental in getting this off the ground. And of course, all of them certainly are, but maybe you want to mention some folks.
Sure. So I'll talk first about my co-founder. So my co-founder, Richard Muller, same last name as me. He's actually my dad. And it's been wonderful to work with him. He is he's a genius. He's an inventor. He's a physicist. He's done nuclear physics. He's done he actually created 2 projects that went on to win Nobel Prizes for the people that he handed those projects off to eventually. He's also a MacArthur genius, and he's our #1 inventor. So he's really come up with most of the breakthrough ideas that deep isolation has patented. So he and I founded the company, but pretty early on, we recognized that we also needed a heavyweight, a heavy hitter when it came to the nuclear industry. And we were extremely fortunate to be able to bring on Rod Baltzer. So Rod was the former CEO of Waste Control Specialists, the low-level facility out in Texas that is also applied to do interim storage for spent nuclear fuel. So Rod has really added a whole new dimension to our work. And he does not just operations and delivery, but a lot of the engineering and the work that we do with partners that include NAC that I mentioned earlier, but also Schlumberger on the drilling side and Bechtel as well. So that's been Rod, and he's been a fantastic asset. We also have Bill Edwards, who is our Chief Strategy Officer. He's been working with governments around the world for his career. He's also based in Europe, which is helpful to us, given that we have a pretty strong focus right now on the Europe, Middle East markets. He's also helping us with our sales efforts, leading global sales right now. And then finally, I'll mention, and this is not the limit. We have some really fantastic team members throughout the company. But Sophie McCullum is our Chief of Staff. She's really my right hand on just about everything. And she also helps by leading up our work on stakeholder engagement, communications, business ops, etc.
Lots of expertise there, and certainly looks compelling that you guys have the right team put together to advance the company forward and get to deployment and so forth. Walk us through the process here. So I want to start off, just talk about the waste deposit operation. So let's say, for example, I'm a nuclear utility and I want to utilize deep isolation services to dispose of fuel rods in my storage casks at my facilities. Just walk us through the process. Where do we start?
Yeah, so you start with taking it out of wherever it is now. So it may be in a dry cask now, or it may be in a pool, and putting it into the deep isolation canister that we're designing together with NAC. So that would be a process that can draw on existing methods for spent fuel handling and put it into a deep isolation canister, which is differently shaped from your typical casks. So most casks have quite a few fuel assemblies in them. We're looking at 1 canister per fuel assembly. So our canister is going to be approximately 15 inches in diameter and 15 feet long. So it'll hold 1 fuel assembly per canister. Those canisters will then need to be shielded while they're on the surface. So it will be a shielding process beyond the canister itself that's not integrated as part of the canister. That will then be transported to the top of the borehole. So presumably the borehole, the deep isolation facility, will have been drilled previously. So we do all the drilling. That will be part of the licensing process, part of what happens before you ever move any of the fuel. And then you gently lower it down into the facility. And when it gets to the horizontal section, you push it towards the end. You then release the canister, pull your hook back up, and then you go and get the next one. So this would be something that is then repeated canister by canister until they are all emplaced in the horizontal section. You then create a bit of a buffer between the horizontal section and the vertical shaft. You fill that, you plug that, and then you fill and plug or seal permanently, if it's going to be a disposal facility, the vertical shaft.
Okay, and there's some illustrations and videos on your website with this process. Maybe this kind of integrates in with the environmental safety and procedures you guys have when you're drilling the holes. Obviously, you're going through potentially areas that might have different geological layers. And then the backfill process, are you guys pumping some slurry, concrete? What's the backfill material and how much are you putting back down into the hole?
Yeah, so that will depend on whether this is a temporary plug versus a permanent seal. So if it's a plug, we would probably use concrete or something that can be drilled out, and we would keep the lining. So the vertical part would be lined with casing, and we would keep that in there to help steer the drill if we drill out the concrete. Once we're ready for a permanent seal, we would remove that casing, which would allow us to really recreate the rock as it was before we disturbed it, before we drilled into it. We would probably have some concrete and might add some other materials in there as well. But the idea would be to do our best to recreate a seal similar to what it was before we went in the first place.
Yeah, and essentially the material is all environmentally friendly material. The casings, the procedures, and so forth really is just adopting standard regulation for oil and gas drilling is my assumption. Is that right?
Yeah, so sort of the drilling in terms of making sure that we protect any water that is near the surface isolate that safely from our facility, that we can definitely draw on all of the best practice of the drilling industry. So that's correct.
Okay, so maybe just give us an example, Liz, of the cost structure for the services. So maybe go back to the scenario I talked about, or if you want, maybe just kind of an average scenario that you guys are expecting a client to approach you with.
Yeah, so it really depends a lot on the specifics. The order of magnitude that we are talking about publicly is that it looks like we're looking at least a 50% savings over a mined repository approach. That varies a lot based on how much waste you have. The more waste you have, the more inexpensive, relatively speaking, the mined repository approach. So it doesn't really impact our costs, but it does impact the comparison in a pretty significant way. The other thing, though, that we are also looking at is a cost comparison with the do nothing alternative. So the sort of keep it in temporary storage option, which is what is happening in most places around the world. And it's an interesting comparison, that one, because the costs of temporary storage are actually pretty significant, and they don't go away with time. They could actually go up with time as things need to be monitored, and there could be degradation over longer periods of time. So not only are we looking at being significantly cheaper than the mined repository approach, we think we can also be significantly cheaper than the above ground temporary storage approach over significant periods of time. Now, what that period of time is will vary, but something like 20 years. We're not needing 100 or 200 years in order to be cheaper than that.
And can you talk just briefly, maybe you can give us a ballpark figure, Liz, just even the example I provided with one fuel assembly, obviously that's going to be the most expensive option, but maybe an entire refuel of one PWR reactor. Any idea on what it would cost to do the drill and to make the deposit, cap it temporarily. Any rough ballparks you can give our audience?
I'll use the US example because that's in some ways a little bit more straightforward. But in the US, the expectation of the amount it's going to cost to dispose of the nuclear waste from one reactor is, and again, this is an estimate order of magnitude, looking at about $1 billion. So pretty significant cost to dispose of the waste from that reactor. We are looking at order of magnitude doing it for about half that. So that's a nice simple number. If you do it based on one borehole, so one full borehole, so a tenth of that waste approximately, the cost will be similar. What is a little bit different is if you only wanted to dispose of one fuel assembly. So if you only wanted to put one fuel assembly into a borehole, that's going to be more expensive. So it doesn't take advantage of the amount of space that we have at the bottom.
Yeah, that's certainly attractive, and I don't think any of the clients would want to do the one fuel assembly, but certainly cost effective, and curious to see how that progresses. Let's talk about pathways to cash flows at this point. And with this, you need to talk about time frame, where you guys see where you guys can first start seeing some cash flow coming out of operations. Maybe you can just give us a year. And then the clients, are these direct relations with utilities? Are you also dealing with third parties like nuclear waste handlers? How does that monetization take place, and what do you think the time frame is?
I can share that we do have our first customers. We did get our first customers this year, so we do have those. But the work that we're starting out with is really the preparatory work. So we are not yet looking at actual disposal. We're not even looking at drilling a facility for possible potential disposal. That's where we're headed, but it's not where we are right now. The contracts that I can mention are a contract that is just about done. In fact, it might be released by the time this podcast comes out with the Electric Power Research Institute. So this is a report that looks at siting a deep isolation type of repository together with siting an advanced reactor. So something that is supportive of the future of nuclear power. There are dozens of advanced nuclear companies now that are looking to move forward and to start to build their reactors, and they need to think about nuclear waste. So this is something that will be coming out soon and includes both looks at the geology, the handling, the cost, and also some of this somewhat sticky regulatory issues in the United States specifically. So that should be out very soon. The other that I can talk about publicly is a bit of work we're doing with a company in Estonia. Again, looking at an advanced reactor, possible future advanced reactor, and they need to demonstrate that they can solve the nuclear waste problem as part of the responsible thing to then allow the development of nuclear in their country. The other ones I can't yet disclose, but I do hope that within the next couple of months, we will be able to talk about them more publicly. So our focus has been mostly on work directly with governments. So in most places, it is the government that has the responsibility for disposal and utilities that have responsibility for storage. We've been talking more to governments than we have to utilities. But I think that is also starting to change as some utilities recognize the importance of finding a storage solution that won't end up double costing them. So they don't want to both have to pay for storage and then have to pay for disposal. So we're actively talking to utilities as well as national governments.
Okay, and Liz, just a few things off of what you said. I'd like you to, if you can, come up with a time frame or let us know if you think that that's something, this first deployment, commercial deployment milestone is something that can be expected in 5 years, 10 years. Think about that for a moment. And then with payment cash flow, do you see that there's an opportunity with one of these new clients coming down the pipeline, upfront partial payment or offtake to help get that going? And then also, I just want to mention that you guys have already done a mock-up. Now, correct me if I'm wrong, but you guys have already done a mock-up where you've essentially drilled, you've done placement, deposit, obviously not with the real canister with the fuel rods, but certainly you've already done a full mock-up. So I want to make sure that's clear to our audience. This has already been mocked up and done. And then lastly, with a company like NuScale, do you think really with the way that things are going as far as total supply chain cradle to grave control, like with a company like NuScale, it makes sense to look at partners that are looking at SMRs and communicating with new advanced nuclear technology to talk about what they do with their material when spent fuel rods ready to go into recycling or into storage or disposal. What's your thoughts on those items?
So let me try and break these apart, quite a few different points. So on first commercial disposal, we think that, so we're already right now doing these initial projects in which we look at the business case for deep isolation disposal at a particular location or with a particular inventory. That's where we are now. We think that the next stage, which is going to have to happen before we can get to commercial disposal, is going to be large scale commercial demonstration. So you mentioned the demonstration that we did in 2019. That was an important milestone for us, but we think that each of our customers is probably going to require their own as well. And that's because not only is it important to demonstrate that technology works, we have demonstrated that already, but we're going to need to take rock samples. We're going to need to show that the particular site that we're looking at can meet those licensing requirements that will be expected. So that's what we're expecting in the, let's say, 2 to 3 year time frame, is that we will be actually beginning to drill the facility. We'll be doing this probably as some sort of demonstration rather than full-scale commercial deployment until we can get that licensing to happen. So 2 to 3 years to get that sort of work going. And we do think that it'll take another 2 years after that to get to the point where we now have a license, we have a facility that's been built, we can go ahead and begin with the disposal work. So I think your 5-year time frame of getting to full commercial deployment of disposal is about right. So that's sort of where we are. So you also mentioned customer payments. Yeah, so that's really an important one for us. We do think that this work would need to be done as paid for commercial work from the customer. Now, we may choose to co-invest in that work because it is strategically important for us as a company, especially for those first few contracts. But this is, governments have the responsibility for disposal. There's a pretty strong commercial argument that this is going to be significantly cheaper than anything else that they can consider. So we would like them to pay for the cost of that demonstration and development work, which we would expect would cost somewhere in the 50 million to 150 million range, depending on the specifics. So you already mentioned the demo that we did. That was something we did in Texas back in early 2019. I think it was important because not only did we show that the technology worked, which is pretty funny actually, because oil and gas people have been using this technology for so long that they couldn't figure out why we were needing to do a demo because this is really pretty standard technology. The technology that we used for that demonstration was all off the shelf. But it was important because it hadn't been done in the nuclear space before. In particular, in the United States, the Department of Energy has tried to do demonstrations of nuclear waste disposal, even vertical borehole disposal, so something that's not so different from what we're doing. And they failed again and again. And so the word on the street as of 2 years ago, before we did our demonstration, was that it's impossible to do a demonstration in the United States. It was expected to fail largely due to public protests, because that's been what's killed other efforts in the past. So the fact that we did the demonstration and we had the full support of the local community where we did the demonstration was a really important milestone for us. And it demonstrated not only that we have the technology that allows this innovation to move forward, but we also have a really strong approach to working with environmental groups and stakeholders stakeholders and communities. And this is my background, so it's a natural fit for our company, but not a natural fit necessarily for some of the other people who have been trying to work in the nuclear waste disposal domain. Final point that you made was NuScale and advanced reactors and partnering with SMRs, and I'm just going to agree with that. I think that the two contracts that I'm able to mention publicly and talk to you about were both regarding advanced reactors. And so I do think that this is an extremely natural fit. And advanced reactor companies and their investors are increasingly recognizing that if we want nuclear to be successful, we need to solve the nuclear waste problem. And that's not impossible. We actually can. We solve the nuclear waste problem in a reasonable time frame.
You made a lot of good points, and the community part of that in Texas, being with oil and gas, partnering with oil and gas folks, the technology, it's simple. It's not cutting edge. It's a very simple process. And so I think that's a huge key. And, the NuScale part of it, there's lots of them. NuScale obviously is leading the way in the US with their NRC approval. Russia's definitely got their stuff going with the maritime applications. We already know that SMRs have been in nuclear submarines, vessels, et cetera, battleships, 50, 60 years, maybe more, commercial vessels, and that's another interesting client, by the way, the Department of Defense for their handling and deposit of their waste. That's an interesting market. And I think the question goes to all of these folks, whether it's Rolls-Royce or NuScale or the SMR leader in Canada, et cetera, that look, you guys are bringing a new product to market, most likely will be commercially deployed at some point later this decade. And what are you guys going to do with the waste? I mean, let's start talking about supply chain, start to finish right now. I think that's fantastic. And you mentioned Estonia, fantastic jurisdiction from what I understand. On that topic, foreign markets, besides Europe, Middle East, are there any other foreign markets you're looking towards? Maybe you can just talk about other foreign markets where you guys are most likely to do this first.
Yeah, sure. So, not much that I can talk about publicly, but we are pretty involved in a number of places in Asia. There has been some real urgency in quite a few places over there. Korea and Taiwan, who have not been able to move forward with temporary storage, surface temporary storage for a variety of reasons, but I think there is a concern that if you put something in temporary storage without having a disposal plan, that you're just creating a long-term problem for yourself, and you're not advancing the solution. So I think there's a real urgency to solving the problem in Korea and also in Taiwan. Japan's another interesting one. They have their own issues regarding Fukushima waste, some real challenges around that. And also the future of nuclear in Japan is really quite interesting. The Americas, we have not been as involved in conversations other than the US, where obviously we're located. We've been doing a lot here, but that's something that I think we will be exploring more explicitly over the coming year.
Yeah, and you guys have some potential clients down south, central South America, as well as you guys advance. And, the Japanese, they're resilient people. They've had a nuclear history written into their books for a long time. They are restarting reactors. They're going through the process. There's a lot of applications for restarts. I think when you look at an island nation like Japan, nuclear is the only option unless they're going to import power from other places. I think that it makes a lot of sense. And I think they realized that as they imported LNG, they dealt with coal, they dealt with some other stuff, but you notice now they're going back. And I think that's a testament to what nuclear provides, their ability to adapt, modify, and improve their industry. So I think that's a very interesting area to look at. Let's talk challenges for a moment. And again, it's a simple technology, Liz, so I don't suspect there's a lot of challenges other than just finding clients, who got to pay their bills. Talk about the challenges you see with this technology and how the company is really addressing these issues.
Like you said, if you ask me what keeps me up at night, it's not the technology, it's not even the engineering. We do have work that needs to happen there, so we're not ready. We're not all the way there yet, but I think that those are issues that will get addressed. So the technology is remarkably straightforward. Of course, it also needs to be tailored for whatever specific environment, geology that we're going into. And there are some challenges there. I will say that some types of rock are more challenging for us than others. So that is an area of work for us. I'll also say that I think one of the big challenges for us is maybe it's turning a moving ship, right? So it's that the industry as a whole has been thinking about nuclear waste in time frames of decades and generations, right? So they don't have this mentality of, oh, we can solve this problem. Yeah, we can do it in 3 years' time. Let's do it. It's much more let's think so that we can have a plan so that in 2050 we'll know what we're going to do with the waste. And that's a real challenge for us. I think that the way that we're addressing this as a business is by identifying those locations where either because of strong leadership that they actually want to get something done in a shorter time frame, or because of need. In some locations, they are not able, as I mentioned earlier, to go forward with temporary storage. So there are locations around the world that have a sense of urgency, and that's where we are focusing our efforts. So that's a challenge for us is how do you identify where there's an urgency? How do you make sure that you have the right people within government who appreciate the need to get things done?
Right. And licensing, social, of course, money issues, capital is always an underlying issue with just about any business these days. Well, how about competitors? What do you guys see out there? I mean, are there any competitors to what you guys are doing, or do you think SpaceX is going to take some waste up into space and blow it off? What do you think realistically? What do you see out there for competitors? Are you guys all alone?
Yeah, so I don't think SpaceX is going to take the waste and blast it off. I do think that the international consensus, if it has to be deep geologic, is going to hold. I think there's some really good reasons for that consensus. In terms of the competition, I mean, there really isn't any right now. I think it would be naive of us to assume that there's not going to be any at some point in the future. But the current competition, I would say that there really is, the competition is really more from the government-led approach than from other companies who are in this space. There's the mined repository approach, which is what most countries who are moving forward with their nuclear waste disposal plans are building towards, are working towards. I think that when you do a line by line comparison, there are things that a mined repository approach can do that a borehole approach can't do. So in particular for big bulky waste, it doesn't make sense to put reactor parts down a borehole. So there will be a role for mined repositories going forward. But in terms of the spent nuclear fuel, in terms of the high level waste, it's a pretty strong argument that boreholes, in particular horizontal boreholes, really make the most sense from a cost perspective, safety perspective, environmental perspective, et cetera. The other approach that's out there, and again, this is typically a government-led approach, is vertical boreholes. So this is something that is more similar to what we're doing. And it's still surprising to me that nobody had thought of using horizontal approaches until deep isolation came along. So the idea, vertical boreholes have many of the advantages of horizontal boreholes, but not all of them. You have to go deeper, and as you go deeper, you have to worry about increasing pressure, and you also have a potential vertical path to the surface. So you have to worry about the damaged zone around the borehole in a way that you don't when you have the horizontal section partitioned off from the vertical borehole. You also have issues of potential crushing. Nuclear waste is pretty heavy stuff. So if you were to put it down a vertical borehole, it's not clear it would be easily retrievable. So that's another approach where I think in most cases, a horizontal borehole makes more sense, but not in all cases. I think there are some geologic locations and for some very small waste inventories where a vertical borehole actually makes a lot of sense. So that's something that we also will offer as part of deep isolation services. We're not wed to the horizontal form. We think it's the most sensible form in most circumstances, but not necessarily always. And then the final real approach that is a competitor to deep isolation is the do nothing about disposal and put it into storage. And that is really what we are competing against in most places around the world.
Yeah, and the capital cost to do that, I mean, you're already talking about the savings that probably be realized there. It's an interesting point. Definitely really destroys and eliminates substantially the thought process that, nuclear waste is a threat to be stolen from a facility and somehow someone can grab a crane and pick that up and heist that material and then have all the centrifuges, all the equipment to be able to reprocess and make a nuclear weapon, which, as you know, is you have to be substantially capitalized to do all what I just said.
Mm.
But anyway, it's interesting because the savings, and you brought up a good point, the vertical versus horizontal, the weight distribution, the fact that you can just go retrieve this. If someone wants to move it in the future, you can just go retrieve it the way you've got it set up. So it's really compelling. Let's move on here as we wrap up. Long-term plans, exit strategy. Do you see that there's maybe a sell-off in the future to a larger industry player? What's your guys' drive and what's your strategy there?
Yeah, so we are actively thinking about various types of exit strategies. Acquisition is certainly on there. I think that once we get to the point where we are working towards disposal at a location, I mentioned earlier that we're looking at sort of $500 million per reactor for disposal, and most sites have more than one reactor. So once we win a first disposal contract, I think that's an attractive time to start thinking about exit. I do think that acquisition is a reasonable expectation, but we would also very seriously look at IPO if that's where we think the right place is for us, as well as continuing to be our own independent company. So I think we're actively planning for a number of different scenarios. But once we hit that first disposal contract, that's really going to be the exciting time when I would expect things to begin to happen.
Yeah, and becoming an operator is a key thing for cash flows. Publicly listed is certainly an option, and of course, acquisition is also another great pathway as well. So, and Liz, wrapping up here, why should utilities and maybe potential other target clients consider deep isolation and the company's services here?
I think that fundamentally, we offer a solution that is probably cheaper than what they're doing right now, that is certainly safer than what they're doing right now, that can potentially address some of the thorny issues that have not allowed them to make forward progress. So the issues regarding environmental justice and transportation challenges and community consent. We have a thoughtful approach to those issues as well. So, I think most people we've been talking to tend to be driven by the cost issue. I think that's a big one for a lot of our potential customers. But the fact that we address all three, that we're cost effective, we're safer, and we address some of the thorny issues that a utility may not be in the best position to address. I think the question isn't why should someone consider deep isolation, it's why wouldn't they?
Right. Also on this, how can investors and other interested parties reach out to you for more information about the company? And also, as you said, they should be looking at deep isolation. What would you say to potential private investors?
Yes. So first of all, if people want to reach me, I'm happy to share my email address. It's just liz@deepisolation.com. So people can reach out directly. They can also reach out info@deepisolation.com. I think that this is it's an exciting opportunity for a number of reasons. First of all, it's an impact investment. This is not just a cash investment. This is, getting behind something that you believe in. And I suspect that many of your listeners really do believe in the future of nuclear power and the future of clean technology. And that's something that we believe in too, and think that this is something that can help us achieve that goal. But at the same time, the cash perspective is also extremely compelling. So we are looking at a very significant return on investment for our investors. That's actually part of the core values of deep isolation, is delivering that significant return on investment, because we believe in our investors, and the people who have believed in us are important to us. So there is a very attractive return on investment for investors, which just, I think, seals the deal when it comes down to people who want to do something that's important for the world and also make a nice cash return while doing so.
Yep, absolutely. I think that should be a very cornerstone part of your guys' strategy and how you guys deliver value. Capital's very difficult to come by. Good capital, good hands. It sounds like a very compelling setup. And I would just encourage the audience to reach out directly to the company and find out what those requirements are, how it works, and go from there. Well, Liz, it's been a great chat. I really hope you guys keep up the efforts. Looking forward to seeing deep isolation expand, achieve commercial success, of course, and we're happy to have you back to update in the future.
Thank you, Andrew. This has been fun. I love talking about this work, so happy to come back anytime.